Good morning to one and all. I am Parthivan working as an assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called satellite communication, which is coming under the regulation R 2021. The subject code is CEC 352. Now I am going to talk about the antenna look angles. In satellite communication, the proper alignment of earth station antenna towards the satellite is very essential for successful transmission as well as reception. To achieve this assignment, we use the parameters called look angles, which include azimuthal angle, elevation angle, and range. These parameters help the antenna point accurately towards the satellite. In this lecture, we are going to understand about the what are antenna look angles are, how they are determined, the geometry involved, and the limits of state of visibility. Let us begin by understanding the basic definition of antenna look angles. What is antenna look angle? It is nothing but the position of a satellite relative to the earth station, which is described by using the three important parameters. The one is called azimuthal angle, the second one is called elevation angle, and the third one is called a range. These are measured by using the coordinate system that is called topocentric horizon coordinate system. Let us understand the each and every parameter. What is meant by the azimuthal angle? It is the angle, is the horizontal angle between the north direction and the direction towards the satellite. It is measured in the horizontal plane. Then elevation angle. The elevation angle is the vertical angle between the horizontal plane and the satellite. Now we are going to see about the range. Range is nothing but the distance between the earth station and the satellite. These angles help us to point the antenna accurately towards the satellite. This is very much necessary for effective communication. Actually, the look angles are in a different satellite orbits, which is depends on the type of orbit that we are using. Let us consider the two types of satellite orbits. The first one is a elliptical orbit. The elliptical orbit is one where the satellite position continually changes relative to the Earth station. Therefore, the antenna must continuously track the satellite. This requires a tracking mechanism. Second, the geostationary orbit, which is also called geo orbit. In geostationary orbit, the satellite appears to be stationary relative to the Earth. Therefore, the antenna can be fixed in only one position. There is no need of tracking. So tracking is not at all required in geo. So this makes the geo satellites are very effective and very useful for TV transmission as well as for broadcasting purpose. For example, in satellite TV communication, it is installed in homes, do not require any type of tracking. Then there are some parameters that are required to determine the look angles. One, we need the first one is it is called the Earth station latitude, which is denoted by lambda. This indicates the north-south position of each station. The second one is longitude, which is denoted by pi. This indicates the east-west position of the Earth station. The third one is, which is located by means of a pi, which is nothing but the sub-satellite path, which is called SSP, we can say. This indicates the position of the satellite above the Earth. We use the various sign conventions. For example, the north latitude is considered as a positive. The south latitude is considered as negative. The east latitude is considered as positive. The west longitude is considered as negative. For example, 40 degrees of south latitude is written as minus 40 degrees. 35 degrees of west longitude is written as minus 35 degrees. These are the parameters that help to determine the satellite direction. That is a geometry in determining the look angles. Now we can say the three important points which are very much needed for locating the satellite look angles. First one is Earth station, which is denoted as capital ES. The second one is the satellite position, which is denoted as capital S. The third one is the sub-satellite point, which is denoted as SS. So these 3 points are very important. So the sub-satellite point is a point on Earth which is directly below the satellite. The distance between the Earth station and satellite is called a range, which is denoted as small d. We use the Earth's average radius, which is a standard value of 6,371 kilometers. This value is used for geostationary satellites. This geometric relationship helps to calculate the look angles accurately. Next one, there are the types of triangles that we can extract from the diagram or from the depiction of the Earth's satellite position from the sun. Actually, there are 2 types of triangles that we will look into. One is called look angle calculation, which is nothing but spherical in nature. The other triangle is nothing but the plane triangle. So this plane triangle helps to calculate the positions, as well as the spherical triangle also used to calculate the angular position relationship. The triangle relationships help to calculate both a range as well as a distance d. The range is depicted by means of capital R. The distance d is depicted by means of small d. From the diagram itself, we can easily observe, we can able to calculate both capital R as well as small d by means of using 2 triangles. The first one is a spherical triangle, the other one is a plane triangle. And next, we are going to see about the plane triangle. So in the plane triangle, we are applying the cosine rule. This cosine rule helps us to calculate the distance between the Earth station and satellite. The distance is called a range. The range is an important one because it determines the signal strength and propagation delay. The sine rule is used to calculate the elevation angle. So higher the elevation angle means the stronger the signal and better the communication. So lower the elevation angle means it is a weaker in signal. Then we are going to talk about the limits of visibility. So the limits of visibility is nothing but it is the coverage area that is called footprint. So this is an area on Earth where the satellite signals can be received. There are east-west limits for the satellite visibility. So these limits depends on one, the Earth station location. The second one is elevation angle. The third one is the satellite position. The lowest elevation angle is 0 degrees. Then at 0 degrees, the antenna points towards the horizon. Below this angle, the satellite cannot be seen. Therefore, it must be above the horizon for communication. So the limit of visibility is an important parameter for pointing out the station. If the antenna points towards the east or west horizon, it reaches the visibility limit. Beyond this point, the satellite cannot be seen. This defines the coverage boundary. The Earth stations outside this boundary cannot communicate with satellite. This concept is important when designing the satellite communication systems. The various references that I have took for this topic are the Satellite Communication by Dennis Rudy, which is 4th edition, which has been given from the McGraw-Hill publications. The next one is the Satellite Communication by Jeremy and Boston. The third one is we can say the Digital Satellite Communication by Tri Ha, which is also under the McGraw-Hill publications. So once again, I thank you all for giving the opportunity to deliver this lecture. Thank you one and all for hearing my lecture. Thank you very much.